S-Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we have learned the differential equation in different types. So we learn more here to the Bessel's function today.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to the S-Chan Academy. My name is Kanhaiya Jha, and today we will discuss this Bessel's function, how it is generally used. So Bessel function is basically a special function. It is basically the calculation with variables. As we can see that we have a variable jbg, which is starting from k is equal to 0 and it has a infinite value. From 0th value it is going to the infinite value. So we can see that here it is minus 1 by raised over k, then it is tk plus 1, then k plus b plus 1 is z by 2 2k plus b. So where z is a complex variable that we can use, the complex number, b is a parameter by which the change is happening, attributary changes, and v is the internal in terms of the output of the function. So here we can see that the particular function is using a particular variable. A particular function is going through a particular change, and then when it is going through a particular change, then it has a change output also that we are calculating. So because of the change in the output also we can calculate here. So we can see that in this final equation we are getting j minus ng. From k value n to infinity we are using this concept. So this is the Bessel equation where one will be the change, one operator will be used to calculate the rate of change, and then we'll use this equation and make calculation. Here we can see that j b to tg is j by 2 minus v jbz. This is the particular value. This value can be changed. We can make the changes here, and when we make the changes in terms of the operator that we use, we come to the particular differential equation that we have. So it is du square by dg square uz plus pg is du by dg uz plus qz in the uz is equal to 0. So we have all the values here. pg is 1 by z, qz is 1 minus v square by g square. So using this we are making the calculation. So u raised to ng is 1 by z u dash g plus 1 minus v square by g square uz is equal to 0. So we have used basically the particular values and we have calculated it. So this is the Bessel's differential equation. As we have learned the different differential equation, so this is one of the simplest Bessel equation where again coming to things we are using the operators, and from the operators we are calculating the rate of change in the particular operators and the operating changes. Again we form an equation. From this particular equation will form how changes will happen, and finally will form a differential equation here. So we have the differential equation here. We can calculate the Bessel equation of the third kind also, where we have different variables which is denoted by h. You can see hv and hv1 and hv2. So we have different variables hv1 and hv2. So using the different variables also we can make the calculation. In the first case, what we have seen here is that we are using the one particular case, we are using the one particular operator, we are using the one particular change in the particular operator and then calculating it. But in this case here what we will learn that next case will be that we are using the two particular operator, and when we are using the two particular operator we are calculating the changes. Here we can see that the operator has hv1 and hv2. Then what we do is hv1g is equal to jbz plus I, and hv2 is this. We will calculate the linear independent with the two particular variables, and when we calculate this we will get the equation hv1g has this particular value which is j minus bz e minus omega minus u by pi. So hv1g has a particular value here we can see, hv2 has a particular value that we can see. Then what we can do is that we can apply them together, and then we will calculate the equation. So here is the final equation that we are getting in terms of the two particular variables. So we are calculating in terms of in this particular Bessel's equation in terms of the two operators HV1 and HV2, and then we are calculating the particular total of the two particular variables. So here we can see that we have J dash G is equal to J1 minus of J1G, Y naught dash G is equal to minus of Y1G. So this is the particular cylinder function, where CV here we can see that generally denotes the particular cylindrical function, and we are calculating the particular boundary values also, and we can calculate it with the potential theory with the cylindrical values. So we can see that when we are using the one particular change in the operator, then also we can use the Bessel equation. The Bessel equation can be used to calculate the particular two variables, and when the difference is occurring with the two variables in this particular equation, and how the boundary effect is generally used, that we are using boundary effect in this, and then we are making the calculation, and then for the boundary effect we are calculating the different range also, different range in which we are making the particular calculation. Then we have this equation, asymmetric representation of the Bessel function. This is another representation of this, where asymmetric representation of the Bessel equation, we take z is equal to 0 and z is infinity. Two values are generally taken. Okay, for z 0 we will calculate with particular this, and then again we will calculate with this particular infinity. So when we can see the equation, we can see that this is the equation for the 0th particular value, and this is the equation for the infinite particular value. For the infinite, we can easily see that h2v is equal to under root of 2 pi z, and then with this is the particular equation. So basically the Bessel equation of the first kind, that will that generally calculate the coefficient. Here we are calculating the coefficient of this. The first kind of the Bessel equation is generally used to calculate the coefficient of the particular given variables. Here we can see that the function is basically plotting the graph, how the graph generally varies in both the particular function, how they are varying with the number changes with n1, 2, 3, 4. Here also we can see that the changes are occurring in terms of 1, 2, 3 and 4. So you can see that either they are varying in terms of the integer, or they are varying in terms of the particular what we generally say is decimal values. They are varying in terms of both the integer and the decimal values both. So we have again the equation here, which equation is basically we have denoted that we have to two particular values. We have taken the two particular values, and from these two particular values we are calculating it. We are taking it 3/2 and minus 3/2. So we are calculating it for the 3/2 and we are calculating it for the minus 3/2, and then we are allocating the particular function. So here we see that we have taken the particular values of variables, and from the particular values of the variable we are calculating that how the change in the variables they can be calculated. We have discussed that how we take the central value and then calculated it. So now we will discuss about the modified Bessel equation. So the modified Bessel equation now we will discuss. The modified Bessel equation is using the first and the second order, as we say IV and KV. So IV function can be used here as from k is equal to 0 to infinity, and this is a particular value. We are using it for both the particular values 0 and then pi/2, and we are getting this equation k and g is limit v to n and then kv2. So here what we are noticing is that we are using both the particular values here, the variables that we are taking, and then after taking the values of the particular variables we are making the calculations. We can see that the variation is occurring in terms of the numbers. The variables, the changes can be occur in terms of the fractions also, but we can calculate both in fraction. The changes are occurring in terms of 0, pi/2, so we can make both the calculation in terms of 0 and pi/2 both. To make calculation with the other types, so we have discussed that how Bessel equation is used in one variable, with two variable, with a modified form, how to calculate the central values in this, and then we made a modification in the Bessel's equation, and then we will calculate it. Now we will take a small break, and again we will continue this. Thank you.
Now quality learning is easily available at your doorstep. S-Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S-Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S-Chand Academy. Happy learning!
Hello students, welcome back. We have discussed about the Bessel's equation. Now we will discuss about the modified Bessel's differential equation here. So differential equation of the modified Bessel's function. So this is the particular IVZ is their definition and KVZ are the linear independent solution of the differential equation. So when we have IVZ and this is the linear dependent solution of this, then V dash g is 1 by z, V dash g 1 plus V square by z square, uz is equal to 0. So here we can see that very clearly that we have 1 is the IVZ which is used, and then again KVZ is a independent solution of this. So we have to come to the conclusion that V dash double dash g plus 1 by z V dash g is equal to minus 1 plus V square by z square Vz is equal to 0. This is the particular conclusion that we have to get when we are using this particular modified Bessel's particular equation. Then Vz is we can use this particular value, and the modified form when it comes to us is WIVZ, KVZ is equal to 1 by z. So basically what we are doing is we are calculating it for the two particular values. As we can see that IVZ is equal to z by 2v, IV minus 1z minus IV plus 1z, and here we are using the differentiation of this which is I dash v. So here what we are doing is we are doing 1 is a value and 1 is a differentiated value of this. So here we can see IVZ and here we can see that I dash VG. Then we are using KV and then again we are using the KV dash G, and then we are analyzing in this particular formula IVZ and an exponential value KVZ. So what we need to have that this is called as a recurrence relation. The recurrence relation, what we have to do is that we have to use the two particular values, and for both the values we have calculated the rate of change, we have to differentiate it, and in the final we have to add it using the exponential values. So this will use the particular two values. The two values can be the extreme values, the two values can be the boundary values, and then we will make this particular calculation, that how in the variation in the calculation that we do. Again we can see that here that IVZ is equal to z by 2v, IV minus 1z minus IV plus 1z, IV dash z is equal to 1 by 2 IV minus 1z plus IV plus 1z, and then we have a KVZ which is solved, and then K dash v, and in the end we are using this particular equation. So basically it is used in the mathematical physics where we do the general expression, the general expansion using the series or using the particular expansion values. We are calculating the particular expansion values, or we are calculating in terms of the series values and all that. We are doing the particular expansion and then we are calculating it. This is a very important differential equation where we are using the two particular values like this and then we are calculating it. Then we have the total value we can calculate here. This is g dash v, g is equal to 1 by 2 gv minus 1 g, g v plus 1 g. So for both the particular values we are calculating this. So when we use this particular value, then it will form a differential equation. So we have make a differential equation here also, where we have put, as you can see in this slide, lambda is equal to 1, p is equal to 0 and q is equal to 1. So by using this, again we are using the two particular values and then we can calculate it. Here we can see that z by 2 n and factorial over z by 2 v over v plus 1. So in both the cases we can see that here the particular values that are coming calculated for both the particular values in this and then make the particular calculation. So what we can do is that we can use both the particular values, and then we can make the calculations in this. Then we have this value k naught g is equal to log 2 by x and then 1 by 2. We are getting this value. Again we will club up both the values and then in this we will find the final equation. We can see the difference in the particular wave equation also, where we have LVX, we have KVX, and then we are using the variables V0, 1 and 2 and showing the variation here. So in the graph plot we are showing the variation. We are using the integer value, we are using both the values, and numerically also we are calculating the change, and graphically also we are calculating the particular changes in the particular values of the variables. Here again we can see that V is equal to 0, 1, 2, where x is between 0 to 5 here. So we can see the variation, that is 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and then how the variations are generally calculated. How we are calculating the different variation by putting them in the different axes, and then we are making the particular equation. So this was the value. Here we can see that how the values vary from 0 to infinity. How we are taking the two particular values. In both the values we are calculating the rate of change, and then we are making the final conclusion or final solution with the two particular values. So here we can see that this is how it happens. In the modified form we will see that how I 1 by 2 g is 2 pi g 1 by 2, where sine hyperbolic g we can easily calculate it. We can calculate for the k particular value also. So again we see that how the two values that we are taking, and from this equation you can see the both the values can be calculated easily. So we are calculating it for both the particular values. So modified form is basically that when we are taking the two values together and then the variation is calculated on both the particular values. We are calculating on both the particular values and then we are making the changes in the particular values and all. Bessel's equation, this equation can be represented in terms of the Laplace transform also. So we can use the Laplace transform also to denote this. So we can see that JVG here is 1 by 2 pi I, then integral here we are using JVG that we are using it here in this equation. We can see that 1 by 2 pi I, the integral, and then p raised to power minus b minus 1 exponential of this will give us the particular result. So we can use in the circular path where p is exponential of this. We can use in the straight path also where we are using this particular value. In both the cases what we can see is that 1 over 2 pi integral of minus pi to plus pi e with this particular value of theta, we can calculate the integral and the changes in terms of theta. Here also we can use the particular values, and we can see in this equation that we can make the changes in terms of the particular calculation. So we say that minus of sine b pi by pi, we are using the integral of the 0 to infinity exponential minus g, and this we are making the calculation. So the final integral that we have is 1 by 2 pi 0 to pi cos v theta minus j sin theta d theta. So we have in this that sine b pi by pi is calculated as exponential from 0 to infinity exponential j sin h s minus vs. So here we are using the Bessel's integral. The integration that we are using is called as a Bessel's integral, and then JBG is equal to j by 2 v and 2 pi I. Using this equation again we can calculate the particular integral form. So here what we can see here that the values that we are taking, and then we are calculating the integral factor of that. After calculating the integral factor we are putting them into the equation and then we are solving it. So how we have taken the integral factor, how we have taken the different values of the particular variable, and then we have calculated it. So we can see here that how this particular variation is generally calculated, how the integral factor is generally calculated, and then how we are coming to the particular conclusion and all. Then we have the Laplace transform pairs. We will in the Bessel equation we will make the pair, and we will do it by using the Laplace transform also. Initially we use the two values. If you see the previous thing that we have done with the modified form, we are using the two particular values and calculate it. Now what we can do is that we can put more values, more different values, and using the Laplace transform we can make the calculation. So here we can see that the particular Laplace transform that we are using it in pairs, JV alpha t is equal to under root s square plus alpha square minus s, then s square plus alpha square. In this equation we can see that this is the particular equation that we are using, and we want to get this equation I v alpha t. So we have to consider the function which is j naught alpha t square minus a square. So we are using this particular values e minus a under root s square plus alpha square, and here is s square plus alpha square. So again we can see that here how we are calculating j naught, either we are calculating I naught and then the alpha, and then we are putting it in the particular equation. So we can see here all the formulas which are generally ranging from the one value to another value, particular value, and how we are making the particular calculation. Then we have the Airy function. Airy function equation is basically complex plane. So Airy function generally use two linear independent solutions. So we are using the two linear independent solution in the differential equation. d2x by dz square uz minus juz is equal to 0. Then WAI, the Airy function here, AIZ, BIZ is equal to 1 by pi. So here we have two particular function, and this two particular function is used in terms of the Taylor expansion. We can see that the two functions here is generally used in the Taylor's expansion. One is AIZ is equal to 3 minus 2 by 3 and 0 to infinity, and we are using this, and then minus 3 minus 4 by 3 value we are using is. Similarly, we are calculating it for the BIZ also, and then we are making the particular calculation. So here we can see that AIG and all this particular omega values, and this is the equation that calculates the change. So this is the basically relation with AI, Z and minus Z, which is forming the Bessel equation. As we can see, VIG and VI minus Z. So these are the again the two particular equation that can be calculated in this, and we can see here that how the values are calculated and how the values are generally used in this particular equation. Then we have a symptotic representation where we are again using AIZ here as 1 over 2 pi square. You can see the equation, and here the BI we are using it. Then the integral representation AIX is equal to 1 over 2 pi I, and integral of from minus infinity to plus infinity we are using this, and then 1 by pi integral of 0 to infinity cos this particular value. So VIX is equal to 1 by pi 0 to infinity, the values we are using it, and then representation for the real variables z is equal to x belongs to IR. So we are calculating it for the AIX and the BIX. So here what we learn is that how we can take the two different variables and then putting into the integral factor or putting into the Taylor's expansion, we can expand it and then we can make the calculation. So we learn now that after doing the integration factor and expanding using the Taylor's expansion, how we can do it in the graphical method, that how the graphical method can be used. So we can see that the expansion are plot into the continuous line in the graphical, and we can see the variation in terms of the particular line in this. So we can see in both, and we can see that where the value of x generally stands in both the cases. So depend upon the value of the particular x, the graph will show the line either increasing or the graph will show either decreasing. So it both depends upon the value of x in both the particular equation. So again we will proceed here, and we can see that how the two variables are generally used to manipulate, how the expansion is generally used, and during the expansion we can see that we can make the calculation using both the expanded particular value. So we can calculate the Taylor's expansion, we can calculate the numerical value, and then we calculate the particular graphical value also. So what we have learned is that the modified form of the Bessel equation, the advanced Bessel equation, we have learned that how we are taking the two variables into account, how we are making the particular calculation, and after taking the two variables, then how to calculate integral factor, how to calculate the Taylor's expansion, and then using the different expansion we will do the calculation. Hope you have enjoyed this video.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.